Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA and your host on the Clinker Factor. So today we're going to look at an initiative from the Climate Group, and this initiative is called ConcreteZero and goes along with other initiatives from the Climate Group to reduce emissions and encourage renewable energy. ConcreteZero is a global initiative that brings together progressive businesses to create a market for net zero concrete. And so these are the users of concrete rather than the producers of concrete. And these businesses commit to using 30% low emission concrete by 2025, gradually increasing up to 100% by 2050 at the very latest. And the idea is to send a strong signal to concrete and cement producers, as well as policymakers and investors, that there is a demand for sustainable concrete. So today I've got two experts and in the field who are involved in this initiative. One is Ben Azoula-Victory, is an independent consultant in concrete technology and nuclear construction quality. He has experience in the construction sector as a quality and environment manager, particularly for concrete frame specialists, and more recently as technical lead on quality and concrete in nuclear defense projects. In May 2023, he set up Love Concrete Limited to support the wider construction sector in sharing knowledge and opportunities in low-carbon concrete. I also have with me Thomas Petithuguenin, who is an entrepreneur who's advocated for industrial decarbonization throughout his career in both aerospace and cement. He was formerly head of research and partnerships at FLSmidth, and Thomas is now the CEO of a Dutch startup company, C2CA, which upcycles waste concrete into high-quality aggregates and supplementary cementitious material. Let me start with you, Thomas, and perhaps you could give any further brief introduction of yourself and talk a little bit about the hierarchy of how you think about getting to low or net zero carbon concrete.
Sure. Hey, Ian. Hi, Ben. Super nice to be here on the Clinker Factor. Yeah, let me try to answer that question as best I can. For a number of years, I was indeed working at FLSmidth on a number of decarbonization projects. And I think, generally speaking, there's a lot of focus on cement plants and the cement industry to reduce its emissions. And one should look at the problem a bit more holistically and look at the entire value chain and what are the solutions in the value chain to reduce the CO2 emissions from the sector. We have a nice word in French, which is sobriété. I'm not sure what the word is in English.
I think it's the same, really, sobriety. Yeah.
Okay. Anyhow, well, it's designating both traditional efficiency, so doing more with less, and also other ways of living that are maybe less material incentive and focusing on waste reduction, circularity, and this kind of thing. And I like this way of looking at the problem. So if we look at the top of the hierarchy, maybe this is the most controversial, but we can start by building fewer things. And if we are going to build new things, try to reuse what was there before. I see a lot of projects where girders, beams are being reused, so taken from the old structure, recertified and put back in. Yeah, sometimes land is cleared for a new residential development project. Instead of that, one should consider redevelopment of old neighborhoods, urban densification projects. I think these things go a long way. So at this stage, it's more at the institutional level. There can be more strict criteria for new construction that don't increase CO2 emissions and reduce the overall environmental impact of construction. Then looking a little bit down in the hierarchy, when we are considering a new piece of construction, there are tools today that allow designers, architects, and construction companies to optimize the type and origin of materials that are used, so that less carbon-intensive materials are used in general. And this can be done looking also at different aspects of the life cycle, so ensuring that materials don't come from far away, or if you're going to use wood, that it's sustainable wood that's not linked to unsustainable forestry, things like that. And then when we get closer to our sector, so to concrete in general, if we are going to use concrete, there's many solutions for so-called binder efficiency. fiber reinforced concrete, strength enhancers. There's a lot of innovation with graphene these days that allow less cement to be used or less concrete to be used in general. A lot of interesting solutions I've seen just with simple particle packing allow less use of cement in general in concrete. So I think these are all really interesting levers that exist. They may not always be the same depending on where you are and what application is considered, but that's the lower level of the hierarchy. And then when it comes to cement itself, which is the one element which is constantly being pointed at with its 8% of contribution to net CO2 emissions in the world. In general, we can use less clinker in cement. There's really a lot of alternative materials out there that can be used as an SCM that can be upcycled. My startup is working on one of these, that's waste concrete, but there's many others. There's a landmark study by Rupert Myers at Imperial College London from 2021, where they just did an inventory of all the waste materials that could be activated as an SCM. And if I remember right, they calculated 3.5 gigatons annually. So this number is huge. And that to me points towards a big untapped opportunity to reduce clinker factor significantly in cement. So only once we've done all of these things, we can look at, okay, the clinker line itself, what can we do there? Shall we implement different form of energy, electrify the system, go for the electrochemical concept, or different concept of calcination entirely? Do we implement carbon capture, et cetera, et cetera? So having gone through this whole hierarchy, what I think is important is different forms of collaboration in the value chain. We can't look at it simply through the prism of the cement plant. We need to look at, okay, how will the cement then be blended and used in concrete? How will the concrete be used in construction? And so on and so forth. And therefore, in my career, but both at FL Smith and now at C2CA, I have worked a lot on value chain partnerships. And that is what interested me about the climate group's initiative ConcreteZero, because it's not really pointing the finger anywhere, but it's trying to create a market for low carbon concrete in general. Yeah, and maybe since Ben is here, he can talk a little bit more about that.
Ben, I think that's a great introduction there, Thomas, and I really appreciate your highlighting this additional dimension that you get when you think about it from the construction end. You know, coming from the cement industry, I know we always used to think this greenhouse gas problem with concrete is a cement problem and cement has got to fix it. But there's just all kinds of other opportunities to reduce carbon footprint at a much lower cost when you think about it starting at the customer end. So Ben, tell us a bit more about this initiative. And I think you're working with the Innovation Center, aren't you? The Low Concrete Innovation Center.
That's right. So within ConcreteZero, we've set up an innovation hub. And the reason, Thomas has already alluded to it, there's so many different clean tech solutions out there. They won't all just be focused on cement. They won't all just be focused on clinker. There'll be changes to standards, there'll be changes to material availability. We certainly know that there's medium-term to long-term constraint issues around the use of GGBS, slag materials with and fly ash as well, with coal-powered power stations and the industry trying to reduce their own carbon emissions. So part of the problem that we realised was many organisations are out there sitting trying to work out what are these most viable technical solutions that they could actually employ? How can they employ them on their or deploy them to their projects? And historically, the supplier-led initiatives have been quite slow in making progress. And what I mean by that is the cement and concrete producers. There's not been an overwhelming advance in the last 20 years in this kind of field. But certainly in the UK in the last 5 years, there's been a real sea change. And I think you can see the ripples of that around the rest of the world as well. There's been such a massive surge in clean tech solutions coming to the fore. But some are more advanced than others. Some of the literature that comes out is more detailed than from others. And I think it's also fair to say there's been a fair bit of greenwash going on over the last few years. And we've certainly seen cement products branded as some kind of green concretes. When you look under the hood, they're pretty much the same materials we've been using in the same proportions for decades, like maybe 50% slag. So part of what the Innovation Hub has been trying to establish is a means of assessing these clean tech solutions in an even-handed way so that you can understand that you're comparing apples with apples. And also, obviously, to cut through some of the potential greenwash, we do still see some of it coming through. And another thing we've also realised is that some of the literature that's coming from these clean tech producers is not necessarily the information that we would need on site or on a project to make a decision on whether or not to pursue that technology. And some of the things that are quite commonly missing are really basic information that a subcontractor needs. Strength development curves, so he needs to know when he's going to be able to strike his concrete, or temperature developments, really basic stuff like that, that maybe from the innovator side that could well be heavily resourced from maybe academic partners, may not necessarily appreciate the kind of information that's needed on a project. And one of the key drivers, or one of the key things about ConcreteZero that's significantly different, is that it is demand-led rather than supply-led. So what we've done, we've developed an assessment template that looks at the technical readiness level of a clean tech solution, the commercial readiness level, the materials abundance on a global or local scale, so the material proximity as well. And we looked at all of these kind of parameters that would help make an even assessment of where exactly in its development stage a clean tech solution actually is. And we've also looked at the potential, obviously the potential carbon savings or carbon impact to the concrete that we're using. And I think one of the other really important things is we've tried to avoid boxing technologies into a corner, but we've focused the categories. We've kind of produced categories that divide these solutions into technology domains. At the highest level, we're looking at clinker, we're looking at cement and cement replacements, we're looking at concrete and concrete products or systems, and then break down into further detail within those each of those groups. So that straight away allows us to, when we post our assessments, we can post them into one of those four categories so that you get a better idea of what you're actually looking at.
Yeah, so I think that's a really practical approach. And it's also a long way from the way that the cement industry thinks about decarbonization, because obviously if you think about it purely from the cement perspective, then you don't really need to worry too much about scope 3 emissions, because almost all of your emissions are scope 1. So there's a tendency to focus on scope 1 emissions, and then immediately that shrinks down the range of possibilities in terms of what you're going to do about it. And one of the things that's struck me in talking to developers and contractors over the last year or so is that they have a very urgent problem, which is much larger than they thought it was. I suspect that when they made commitments on reducing their carbon footprints, they hadn't quite recognized the degree to which scope 3 was their main issue. And in the presentations I've seen from contractors in particular on their progress, they show good progress on scope 1 and 2, which I guess is, changing their company cars to electric probably. But on scope 3, which is 90% of their emissions, they show no progress at all. And so I think one of the, I recognize is that their ultimate customers, their end users, are really under pressure in some markets to make very rapid progress, and they must make progress on concrete to meet their overall objectives. In looking at it from that end of the spectrum, Ben, what are the key barriers that you see currently? I guess primarily you're focused in the UK, and if we just focus on the UK market for a moment, what are the key barriers that you see in making progress towards achieving these low concrete goals?
You're right. It is very much the work that we've done so far as ConcreteZero has been very UK centric at the moment, but it's intended as a global initiative. So the next steps with some of the work that we've done is to make it more applicable on a global level. It's also right to say that scope 1 and 2 they're the easy wins, really, because at the very base level, you've got an electricity meter that you can read the amount of energy you're using and monitor it and measure it really, really simply. That is one of the key challenges with monitoring and measuring our carbon impact with concrete, because there is no one single baseline metric out there that you can follow. There's certainly within the templates that we've worked with within the UK, there's the Institution of Civil Engineers database version 3, which contains baseline carbon values for most binders, but they lump all aggregates together irrespective of where they've come from, whether it's coarse or fine aggregates, whether it's gravel or crushed marine. There is the Mineral Products Association Fact Sheet 18, which again covers a lot of binders, but doesn't go into any great detail on a lot of other materials. So getting a single point of reference for all of the constituents that go into concrete, it just isn't anything out there at the moment that's holistic. And what there is out there is generic information. So a good example being the MPA fact sheet 18. That's based on data from their MPA members, which covers about 80% of the UK concrete market. And there's quite a wide amount of variability between those suppliers as well. So the accuracy of the information of the baseline data is a challenge. What we want to be able to get to is a point in time where all of the concrete materials and all the constituents are provided with a reliable carbon declaration, so that we can make accurate calculations. But I don't think the infrastructure for delivering accurate data is there yet for all products. The maturity maybe rather than the infrastructure. I think that's probably the biggest challenge that we start with. How do we start measuring carbon footprint? And that's where any organisation on its zero path needs to start with. How are we going to measure it? There's quite a lot of other challenges. There's so many working groups and associations out there working on different aspects of this, which can be a challenge in itself because you're looking at the same thing in slightly different ways. And I think off the top of my head, one of the good examples of this is the low carbon concrete group benchmark data, and a market benchmark that's got a really good rating system for a bit like when you buy a fridge and you get an energy performance rating system. They've done exactly the same sort of thing for concrete. That's very much focused on data produced from within the UK. Then aside from that, there's also a benchmark rating system produced by Arup and Innovate UK, which uses a similar sort of scale, but they're not quite exactly the same. So there's actually been a bit of work done over the last year by LCCG and ConcreteZero to work out how these two baselines can work together. We also know that there's more baselines out there coming out from GCCA and others. So this uniformity of data is quite a challenge. Some of the other working streams have been looking at one of the biggest thorny issues, I think, is how do you actually specify some of these clean tech solutions? If they're code compliant, something like calcined clay cements, which are already in EN 206 and BS 8500 or EN 197, they're a lot easier to specify. If you can get the material, then technically you can use it in your concretes and it's code compliant, and that should be quite pacifying for most stakeholders on your project. Might still surprise a few people when it comes out a funny looking colour because they're expecting grey, but all things said and done on the technical level, it's relatively easier to specify than a product that falls completely outside of the Eurocodes. So the approach to actually specifying your products is or your clean tech solution is quite important. Some of you listeners will know that there's a Flex 350 standard that was produced. I think earlier this year was first version was released. The second version is due this month, and that is aimed at trying to assist the specification of alternative binders that wouldn't necessarily fall under the Eurocodes.
Yeah, so thanks, Ben. So measurement, the whole sort of benchmarking and specifications being big topics. Thomas, if I could come over to you, you're based in Holland, and of course, from a UK perspective, we always think that Holland has been doing a great job on recycling for a long period, possibly because there aren't so many aggregates, available. But what's your perspective in Holland and more generally in the European markets? Are the challenges more or less the same as they are in the UK, or do you think there are some distinct differences between the different countries?
I will start by speaking about the Netherlands, which is where we are going to market. The Netherlands has invested for many years on circularity, as you say, primarily because it's not rich in mineral resources. So they don't have so many rocks that they can brush into aggregates. They don't have so much sand, and they import all their cement. They're also importing all of their supplementary cementitious materials. So there's a great desire from the government to be more independent, less dependent on imports, and therefore implement circularity solutions. And so this effort started about 10 years ago. Both the government and industry entered into something called the Beton Accord, so the Concrete Accord, aiming for specific replacement targets of aggregates with recycled aggregates, sand with recycled fine aggregate, and then also having specific goal in terms of reducing the carbon footprint overall of concrete. And these do go a long way because they are then reflected in public tenders. So most of the construction companies that are responding to public tenders have to meet certain pass-fail criteria on replacement rates of aggregates in the concrete they use. and also on the embedded carbon of the piece of infrastructure that they're going to build. And that's actually how we have been able to set up our first commercial partnerships, is because there were construction companies that really wanted to maintain market share, be in advance, meet all of these criteria. And they were looking for solutions to replace virgin aggregates with recycled ones, and also to use high volumes of SCMs. And they just didn't have these solutions available on the market. So they scoured the market and found different solutions, including C2CA, so my startup. But so we're not the only ones benefiting from this. But by having the end user of the material really wanting it, they find a new tech, and this then helps the middleman, so the concrete factory, to accept our materials and work with us, get all of the right data that's needed, get that end user acceptance, so that then this material can go to market. So I do once again believe in this value chain collaboration, and that by getting the end user to want the material, you really help the other side of the value chain to change the way it's producing. So having said that, I don't think it's automatic. The product needs to be compliant with standards. There's no avoiding that. So that's a big challenge, I think, for any new material, and not just for startups, that we need the standards to evolve, not just for cement, but also for concrete. Here in the Netherlands, I think we're in a very good position, because there's, on top of the standardization committees, there are agencies that produce guidelines for concrete producers to use alternative mixes, new mixes, even though they're not standard compliant, and they can do so legally by following these guidelines. And the last element is the CO2 reduction does indeed need to be verified and reliable. So I think nowadays, one cannot simply make a claim and people will just accept it. Everyone wants third-party verification. And here, again, I know the situation of the Netherlands quite well. There's a national environmental database, the NMD, where there's a large number of concrete mixes with innovative mixes using new materials, where their LCA has been third-party verified independently. And when construction companies use these, they can refer to this NMD and then use that to inform their Scope 3 emissions reporting. So that does work. And I think the key part of it is that it's third-party verified. You cannot just do it on your own and then submit that to your customer, the construction company, and have them report it. And the last element is the cost. For sure, we cannot expect a green premium for new materials. Perhaps that would be the case in some niche markets, but the new materials we produce do need to compete on cost and quality with the existing alternatives that they replace. So that's a little bit about the Netherlands. I think Netherlands is in advance of many other countries, but I see similar trends in Denmark and Sweden, in France, in Germany. Some countries are much more in advance than others when it comes to replacing aggregates, some much more in advance when it comes to SCMs, simply by virtue of what they're producing locally in terms of alternative industries producing secondary raw materials that are then used in cement. But in general, I see, this is a trend happening all over Europe.
Okay. I just come back to this green premium question. I've come across two markets in which people have said they can get green premiums. One is Sweden, one is Finland. Again, in both cases, I think it's niches within the general market. But I was also in discussion with somebody in the UK recently, and they were planning to buy, this was for precast, but they were planning to buy cement from Heidelberg's Brevik plant, the sort of decarbonated cement, which they expected to pay a very high price for because they felt they could get a premium on basically a zero carbon or near zero carbon range of materials. So I think, as you say, Thomas, it's probably niche still, but there are some indications that at least there's some appetite sufficient to not just say, yes, we'd love it to be low carbon, but we're not willing to pay any more money for it. But actually, some people are willing to pay a little extra.
Okay, let me rephrase that. Because for sure, there are buyers that are willing to pay more to have something which is certified low carbon, both for reporting to satisfy their stakeholders and also for ethical reasons, because they just don't want to have a high carbon material in their construction. Nothing wrong with that. My point is more that Europe and other markets that have let's say a carbon tax or a carbon trading mechanism, that's a small part of the cement and concrete market globally. It's maybe 10% of cement and concrete globally. If we do want to have a big impact around the world, and that's mainly Asia,
yes,
China, India, Southeast Asia are the biggest consumers of cement, then we need solutions that are cost competitive over there.
Yes, absolutely. Ben, can I come to you on this standards point? So I've talked to several contractors who were saying that the standards are not entirely limiting, in the sense that if they wanted to, they can go outside the standards. They have to make a case for it to building control. But to what extent do you see the standards themselves as being a barrier to progress?
That's a really good point, actually, that you don't have to follow the standards, but to actually deviate from the standards takes a lot of buy-in from everybody involved. All the stakeholders involved in your project are going to need to have full buy-in on that. Eurocodes do have, it's not a backdoor so much as a caveat that if you want to use alternative materials, the route to do that is to do design assisted by testing, by which the designer creates his design, he makes his design assumptions, and then you embark on a course of testing of the materials to get empirical evidence to validate your design assumptions. And when that data comes in, you can then adjust your design accordingly. That's not, in the grand scheme of things, not necessarily so expensive. Done a design assisted by a testing package for a product for a client, which took about 18 months to complete. I think the cost would work out around about £200,000 for all of those tests for a number of different mixes. £200,000 in a grand scheme of a major project is tiny, but what is important is that needs to happen way in advance of starting work on site. So you're really looking at RIBA stage 2 or 3. And fundamentally, this is where the ICE route map to lower carbon concrete specification comes in, is you need to have the buy-in from all of the stakeholders, fire assessors, the building control, the insurance companies, the architects, the clients, the structural engineers, the concrete producers. Everybody needs to be involved in designing the testing regime to make sure that they're getting the type of data that they need, the volume of data that they need. So that's really where the big challenge lies with that route. The BSI Flex 350 standard is aimed at trying to make standards more accessible, make it easier to specify lower carbon materials. It is focused on alternative binders, that's the title of the document, or alternative binder systems. So again, that can be limiting slightly as well. But the principles that it covers, it includes a guidelines on how to go about getting your alternative materials into a specification and validating the use. There's so much work going on the standards. BS 8500 last year was revised to allow ternary blends, so we can now legitimately include our limestone fines as part of the cementitious content, whereas historically we were all calling it an aggregate to use as a filler, but now we can include that as part of the cementitious content. But it does open the door for wider reduction of CEM1 use in our mixes. I think the standards have been a point of comfort for a lot of structural engineers and designers. There's historically, in my own experience, there's not been a huge amount of willingness to step outside of the safety of those standards and the formulas that are within the Eurocodes. So getting to sit with a structural engineer or a designer that's willing to go back to core principles and design based on live data rather than using the comfort of the very conservative functions within the Eurocodes is another challenge. So it's not just as easy as just we do the testing and we use those data points. It takes a lot of confidence from everybody involved, I think. But there's a good core, I think, of clients, engineers and contractors and the like that we've been working with in ConcreteZero over the last couple of years that have got that willingness. Thomas, you touched on different levels of advancement around Europe. I'm led to believe that in America, when they do a trial of an innovative product, they go and do 20 kilometers or 20 miles of motorway, or they build a 20-story building. So the volume of data that you get from that kind of trial is immense, but they're not necessarily, as far as I understand, as advanced in the communal thinking and the strategy of delivering this kind of initiative. Whereas in the UK, we're completely the opposite. We've got great workshops and initiatives going to give guidance on how we should go about doing these kind of trials and initiatives. And we've got great incentive to do them. But when we do, we have a 3 cubic meter load of concrete turn up and we do a bit of blinding with it. And we might do a hot box and we take a load of cubes. But so the scale of what we actually do with that is very, very different. We obviously want to get to a point where we can get the best of both worlds, where we get this great attitude and maturity of thought married up with great aspirations for big projects.
I can just quickly react on the standards. Even when a new cement blend or new material does become specified in the standards, that's not necessarily going to open up a big market immediately. So we've also seen that a little bit with calcined clay. What I think it takes is for one big lead user, one big consumer to say, yes, we're going to use this, we're going to place a big order, and then that makes a lot of other parties at ease. As far as I've heard the story in the US, it took the Department of Transportation to accept using Portland limestone cement before everyone else started doing so, and then it was an overnight change. And maybe that's what it takes in each country. In the Netherlands, it'll be the RWS, the Ministry of Infrastructure and Waterways. Once they accept the material, then everyone else is comfortable with it.
Yeah, no, I think that's a great point, Thomas, and I think that also highlights the role that government can play in public procurement, because getting people started and comfortable with a new solution is not just about it being within the standards, right? Because everybody is used to doing things one way, and it's not straightforward to get people to move away from something they know works and they're comfortable with, and so forth. So I think that's a very good point, and also, Ben, you were talking about the design opportunity by doing things a bit more from first principles rather than accepting the standard shortcuts. But there's a whole raft of things that can be done in the supply chain to reduce over-specification, over-ordering, and wastage generally. So I think, perhaps the context to put this in is that if you are only caring about cost, as we have historically, then concrete is, perhaps 2% of the project costs. But if you care about carbon, then concrete's 35% of the project's carbon. Suddenly, it's much more relevant to do those things that can eliminate wastage in the supply chain. So I think that the focus of this initiative from the climate group is very interesting, because it really puts the focus on the customer end. So that includes the whole supply chain, rather than just thinking about it as we have traditionally in the cement industry as being a cement problem. So look, it's been fascinating talking to you both today, and thank you very much for your input. So Ben and Thomas, thank you very much for joining me today.
Thank you.
You're welcome. Thank you.
Thanks for listening to the Clinker Factor podcast today. If you've enjoyed it, do subscribe, and please recommend us to friends and colleagues and anyone else who you think would be interested in what's happening in the cement and concrete industry around the world. WCA is a not-for-profit company. Please visit our website to see the services that we offer